the state evaporated. The useful thing I had summoned went back into vapor. Okay, let's just dive right into this. Listen, if you've ever worked deeply with large language models, you know exactly what Tony means here. It is literally one of the most frustrating things. You spend, what, an hour building up the absolute perfect context? The AI is finally giving you brilliant, nuanced answers, and then the session ends. The context fragments, the prompt drifts. Basically, every time you start a new task, you're forced to rebuild the machine's entire understanding from scratch. And this right here, this was Tony's original problem. He was losing useful AI thought between sessions. He wasn't trying to build the next massive AI startup. He was just desperately trying to build somewhere safe to put unfinished thought.
So, welcome to this documentary explainer. Today, we're tracing a really raw, scarred engineering journey. We're going to look at the evolution from experimental, highly fragile AI agents, the ghosts in the machine, to a durable, governed, and heavily structured system known as GhostMesh. Now, I want to be clear right up front. This is not your typical, polished, everything went perfectly product pitch. No way. This is the real story of systems engineering. We are preserving the brutal failures, the rollbacks, and all the messy, unfinished work along the way. We're telling the human story right alongside the engineering story, completely unvarnished.
Part 1. The problem of disappearance. Let's get right into the foundational issue.
Looking back at 2024, Tony first approached this by trying to build what he called an oracle, basically an immortal artificial mind. The IMMOTMOR experiments assumed that if he could just preserve the exact state of the chat, or maybe if the model could just remember enough of its own identity across sessions, he'd solve the amnesia problem. But as it turns out, that assumption was completely backward. It was like chasing a mirage. You actually can't force permanence onto a system that is fundamentally designed to be ephemeral. As we move through 2025 and into 2026, navigating a bunch of false memory breakthroughs, the real architectural shift finally clicked. Tony realized that continuity just couldn't exist inside the model. Think about it. If you depend on one single cognitive presence never failing, you don't have a resilient system. You have a massive, single point of failure that will absolutely crash on a random Tuesday morning. The continuity had to be externalized. The intelligence didn't need to be immortal. The system just had to survive without it.
Part 2. Get an externalized continuity. And this is exactly where the big paradigm inversion took place.
Tony stopped trying to invent some magical, futuristic AI memory layer, and instead, he just turned to old-school software discipline. We're talking Git, pull requests, continuous integration, rigid deployment pipelines. He realized that this decades-old infrastructure, which, remember, was originally designed to coordinate distributed human teams, was actually the perfect answer to AI amnesia. Contrast the old way with the new. In the old way, treating the fragile chat window as the system of record creates this conversational cockpit that can literally vanish with a single errant browser refresh. It's a nightmare. But by applying strict Git discipline, the repository itself becomes the durable memory. The issue ticket becomes the intent and the absolute authority. The continuous integration pipeline, that acts as a mechanical skeptic, ruthlessly checking the work. Suddenly, you, the human, retain total authority, and the AI agent is demoted to exactly what it should be, a temporary worker that processes a bounded task, drops its output, and gets out of the way.
Now, why does this philosophical shift actually matter? Well, because of this number right here, 51. In late July of 2026, GhostMesh hit a massive scale inflection. By externalizing the state and treating the AI as just a temporary worker, the AI actually removed the implementation barrier. To put that into perspective, in a single 4-day window, one engineer, Tony, was able to coordinate 51 merged pull requests across incredibly complex repository architectures. The scale of what one single human could govern absolutely exploded. And why? Because he wasn't writing every line of code anymore. He was managing the workers.
Part 3. The scale of one engineer and manual ignition. Now, as with literally all true engineering stories, fixing one huge bottleneck immediately exposes the next one.
So, we move from the incredible scale of the architecture to its biggest remaining flaw at the time, manual ignition. The machine itself worked beautifully, but the spark to start it was still highly dependent on a human hand. Tony had built these incredible operational surfaces, right? You have SharePlane to preserve meaning and artifacts, Control Tower to expose live machine state and execution telemetry, and Tony Brain for semantic memory. But here was the reality. The mesh was there, but Tony was still acting as the world's most overqualified human transport layer. He was in there manually copying prompts, checking stale claims, kicking off pipelines, and painstakingly carrying context between these beautifully designed but totally disconnected surfaces. I mean, it was an exhausting way to run what was supposed to be an automation system.
Part 4. Crossing the trust domains. To truly make this system hum, it needed to cross boundaries without Tony having to hold its hand like a nervous parent.
This brings us to a huge breakthrough for GhostMesh, crossing the trust domains. The system finally began executing real, verifiable work across entirely different repository boundaries completely on its own. Let's walk through the exact technical receipt of how this happened, specifically the skills high trust crossing. First, a signed owner event is admitted. Human authority is established right off the bat. That's crucial. Second, the platform crossing is initiated, meaning the system reaches out to a clean runner. Third, and actually this is the most important part, it completes the task and then explicitly revokes its own temporary credentials. It cleans up the workspace, it returns an HTTP 401 unauthorized proof. This proved beyond a doubt that the fabric could handle high-trust, multi-path validation and then cleanly lock the door behind itself. So what does this actually mean for the economics of AI execution? The architecture strictly distinguishes between execution classes based on cost. Look, if a direct connector can do the job, use it. It has the lowest cost profile by far. If a deterministic script can test and deploy, use that. You only deploy the expensive, heavily compute-intensive, model-backed AI for the novel reasoning delta. That's it. The goal of GhostMesh isn't to just maximize AI usage for the sake of it. The goal is the minimum trusted completion cost.
Part 5. Operability, Failures, and Silent Pickup. Remember how I said earlier that this explainer is not a victory lap? Well, here we go. The moment this sophisticated system scaled up, the harsh reality of distributed systems kicked the door down. Real defects emerged immediately. Moving from impressive architecture demos on a whiteboard to actual daily operability is painful, it's messy, and it is full of withdrawn claims. Here are the specific glaring failures Tony ran into. First, silent pickup. This is where a command is accepted by the system, but it just sits there, unclaimed in the void, with no runner attached. Your ghost literally ghosted you? Second, ambiguous worker states. This is where it's practically impossible to tell if the AI is genuinely working on the problem or just frozen in an endless loop. And third, false owner-ready handoffs. These are the worst. This is when the continuous integration pipeline is mechanically green, the deployment happily reports absolute success, but when the human owner clicks the user acceptance testing link to verify it, the page is completely broken or just loads infinitely.
Experiencing these failures led to a profound foundational realization. A command is not execution evidence. Just because you enthusiastically mentioned an AI agent in a GitHub comment doesn't actually mean the work is happening. Elapsed time means nothing. The durable record must reflect exact terminal receipts. The execution continuity had to be externalized just as much as the memory and the authority had been. The state of the work can never, ever rely on a lost mobile client or a closed browser tab.
Part 6. When the provider failed. Just as Tony was grappling with all these operability gaps, the entire mesh got hit with a massive stress test.
On August 6, 2026, the core external provider failed. GitHub Actions and Pages suffered a major outage. Webhooks throttled, queued lanes stalled completely because there were no runners, the whole system basically ground to a halt. But here is the incredible part. Because of the strict Git discipline and the externalized state we talked about earlier, the mesh just paused safely. It was a perfect example of bounded recovery. The system didn't panic and hallucinate a fake completion, it didn't corrupt the data, the jobs just sat exactly where they were, perfectly preserved in amber, simply waiting for the infrastructure to return. As Tony noted in an exact first-person receipt of the incident, the mesh prevented silent corruption more reliably than it prevented wasted motion, confusion, or owner overload. This is fascinating because it proves that the safety plane of GhostMesh actually matured much faster than the operability plane. It became exceptional at containing damage and preserving state well before it became good at reducing the human owner's daily cognitive burden.
Part 7. Sovereign Execution and Commissioning. That August 6th outage? That was a massive wake-up call.
It catalyzed the next big architectural shift for the system. Because think about it, if your entire system relies on one cloud provider's orchestration, you aren't truly resilient. It was time to move toward sovereign execution. Now there's a big difference here. Being provider neutral just means your code could, conceptually, run anywhere if you had to pack up and move it. But provider independent, that is the actual goal here. This means your execution relies on independent orchestration and sovereign local compute. Your local, high-capacity workstation becomes an isolated execution node. You aren't just relying on self-hosted GitHub runners anymore, you are completely separating the forge from the compute, fully securing your system against external collapse.
At the exact same time, we see the memory plane, Tony Brain, being completely stripped of all its AI mythology. Instead of just lazily dumping 200,000 messages into a vector database and praying the AI magically figures out what's important, the system moved to strict, measured lexical retrieval over a tightly bounded corpus of just 50 conversations. The principle here is absolutely crucial for any systems engineer. Do not scale uncertainty. You prove the contract on a small slice, you preserve the exact evidence, and only then do you expand.
Which brings us to the ultimate question that defines the current commissioning phase of this architecture. Moving past those flashy capability demos, moving past crossing trust boundaries, the real question is, how do I make a governed machine work system reliably operable for the human who owns it? How do we build a truly dependable operating system out of what is inherently temporary intelligence?
What the final engineering takeaways give us the blueprint. 1. Accepted work cannot disappear into silence. Ever. 2. Owner gates must perfectly externalize the exact question and the consequence so the human is always in control. 3. Provider outages must be treated as explicit external state, not mystery failures that leave you guessing. And 4. Execution must automatically route to the least expensive valid class. That right there is how you transform flighty, temporary AI workers into a durable, accountable continuity system.
So, as we wrap up, when you're integrating AI into your own workflows, I want you to remember this core philosophy. The ghost can disappear, the continuity must not. So ask yourself, if your AI agent evaporates right now in this exact second, does your system's progress vanish with it? Thank you so much for joining me on this explainer, and we will catch you next time.